Thanks, everybody. Thanks, Jim. I'm Fabio. As we said, I lead the engineering team here at Hopsworks. And today we're going to be taking a look at how to use feature stores to build a machine learning system. Why is that, right? So if we start looking at what is MLOps today, right, and what does MLOps do over the past couple of years is what I consider a massive spaghetti code, right? This is from one of the more cited paper on MLOps architecture. You can see there is like arrows going everywhere, components everywhere, and it's really a complex system that is hard to build, hard to manage, and in generally speaking, quite fragile, right? And one of the reasons for that is, and I believe, is that the deploying model to productions is actually a data challenge, right? So the architecture that we can see here is actually meant to address the underlying problem of managing data for AI. And there are actually a couple of different challenges that we can look at. These are the challenges that every time we talk to someone about Hopsworks and about feature stores, these are things that come up over and over and over, right? So the first one being, when I'm building a model, I'm usually relying on a variety of data sources. I'm not relying on a single CSV file or like just a bunch of data on a data warehouse, but I'm drawing data coming from streams. I'm coming data from data warehouses, data lakes, spatialized database like graph databases, and I'm throwing everything together to be able to build a model and make predictions. The second challenge is that there isn't one single tool to do any of those tasks, right? There is a bunch of different tools to do feature engineering. There's a bunch of different tools and frameworks to train models and serve them. And there are new tools coming out every day and every year, right? So for instance, stuff like Polars or DuckDB a couple of years ago were not well known, and today they are pretty much everywhere, right? Another thing that it's quite important that we see over and over is this connection between there's a disconnect between what like for instance it's experimentation compared to what maybe it's training or production, right? So you have different teams kind of taking care of different stages of the, let's say MLOps process, and then there are walls and there are situations where you throw your work over the wall to the next team or the next person responsible for it, and that obviously creates frictions and creates points of failures and things like this. One other thing that we see often is that there are oftentimes custom, like one-off bespoke pipelines to do different things, right? So a team might build a pipeline to train a model. It's taking data from a data warehouse, do some transformations, and train a model. But then the same model needs to be served in production when you got time behind the REST API, and the team goes off, or some other team goes off and build a totally different pipeline that maybe relies on a Kafka stream or maybe relies on other like technologies underneath. And then it's a nightmare to keep those things the same, right? So these are kind of the eye level challenges, and feature stores to a large degree try to address those challenges. But what we found is that tools only get you so far, right? So the challenges, you can't just magically drop in the feature store and all the challenges go away. You need a proper process in place. So we work with users and we work with customers to try to identify some of the patterns and things that we obviously make for a successful implementation of a feature store, right? So the goal for us is to go to a complex system like this to a more well-defined system, a more simple system to understand and reason about, which is the FTI pipelines. We call it FTI pipelines. FTI stands for Feature Training Inference Pipeline. And the goal is essentially to split the process of developing a model and deploying a model into production into three independent logical components, which are responsible for different parts of this process, right? So we have feature pipelines that are responsible for reading the data and computing the features and producing those features. Training pipelines are responsible for actually building the models, and that includes everything from experimentation and actually training the model, the final model. And finally, we have the inference pipeline, which is responsible for taking the model and making inference both real time or also in batches. These are independent components. The nice aspect about this is that you can reason about every single component individually. You can have, for instance, different teams working on different components. You can have different. You can use different frameworks. You can orchestrate, for instance, the different different pipelines independently. So you might have a feature pipeline runs in a streaming way. You might have a feature pipeline that runs in a batch fashion every day, but you might have a training pipeline runs once a month or something like this, right? So the idea is not to have a single unified pipeline, but you have actually split them up. One thing that is missing here from the picture is how the three different pipelines work together to build these ML systems, right? And that's where Hopsworks comes into the picture, right? So Hopsworks as a feature store provides the capabilities to manage the artifacts, to manage the features, to store them and serve them and so on. But it also provides an open API, which are in Python mainly, but also available in Scala and Java to be able to actually interact for these pipelines to actually interact with the feature store, right? So if you are writing a feature pipeline, then you will call the API to register the features with the feature store. If you are writing a new training pipeline, you will need the API to retrieve the features from the feature store, and also for the inference pipeline and so on, right? So Hopsworks provides the capabilities for these three pipelines to share the outputs and build on top of each other, while keeping them separated and independent. Now, if we look a little bit more in detail about the different steps, so if we start from the feature pipeline, right? The feature pipeline, as we've said, is responsible for computing the features and producing the features and potentially also the labels if necessary, right? The expectation is that you have a really clean system where basically you get a bunch of data and you do transformations, and then there you go, you basically have your features. As we said earlier, like one of the challenges that you have when you're building machine learning systems is that you're dealing with a bunch of different data sources with different timelines in terms of ingestions. So you might have, like I said, a streaming pipeline coming in that needs to be processed in real time. You might have a data warehouse, that is loaded once a day, once a month. You might have, existing pipelines that you need to combine. So there is a lot of complexity and a lot of different tools and different processes that are required. One of the challenges is that you don't have one tool to rule them all. So you don't have one single framework to do everything, right? So you have different frameworks, and different teams actually prefer different frameworks, right? So if you, for instance, if you're working with small data sets, you can probably get away with pandas and polars. Maybe you're dealing with streaming API with streaming data. You might want to look at stuff like either Beam, Flink, or Spark Streaming. You might have data and data warehouse, so you might be looking at BigQuery, Snowflake, and leveraging their execution engine and so on, right? So there's different tools and different pipelines have written different tools, and they need to be combined with each other, right? The idea and the benefits of the feature pipeline is that all this complexity is actually hidden and taken away from the rest of the training pipeline. Inference pipeline is all combined into the feature pipeline. Hopsworks has always adopted a philosophy of being an open platform, and the feature pipeline kind of adopts that philosophy as well, to basically allow different frameworks to be used. Not only the frameworks that exist today, but also future-proofing your infrastructure and the infrastructure of our users and customers, so that if, let's say, in 2 years from now, the next activity comes out or the next portal comes out, we can plug it in and you can leverage it to compute features, right? You don't have to wait for a specific tool to add support in the DSL. It's just use it and call the API to register what we call in Hopsworks register data frame. Data frame are a common concept across all the data processing tools out there. That's essentially what we provide in terms of platform to implement the feature pipeline API. One additional thing that actually is something that it's new in Hopsworks that we have released as a preview right now it's feature monitoring, right? So the goal is that when features leave the feature pipeline, everybody can trust it, right? So if I'm a data scientist building a training pipeline, or if I'm building like an inference pipeline, I know that the data coming in the data that's available in the feature store is actually high quality and correct, right? Hopsworks has had support for great expectation for many releases now, and that's mostly covering bad data. So, for instance, I have nulls in my data, or I have negative values when supposed to be only positive. These new capabilities, feature monitoring, actually looks at more statistical data, statistics properties of the data, and making sure if the data is shifting or drifting, you can basically get an alert, and you either retrain your model or adapt your model essentially. And we have, again, open Python API to do that. It's the same API for batch, and the same API to monitor real-time pipelines. And you can basically have a look at documentation is going to be available soon as well to look at this API. The next step is, once the feature has been produced, is actually it's time to actually train a specific model. Training a specific model, again, the underlying concept is the platform needs to be able to support all the different frameworks that the scientists might want to use, right? So everything from deep learning frameworks like PyTorch and so on, but all the way to, let's say, if you're working with tabular data and so on, you might want to look at, I don't know, XGBoost or scikit-learn or something like this. So for Hopsworks and for feature stores, the key concept here is to provide an API to give back Pandas data frame, right? Hopsworks supports it. All the feature stores out there, they support the same API. One important aspect I would say that you really want to be careful about is the way you're retrieving data, right? So if you look at feature store out there, and to a large degree, Hopsworks back in the days, they are either built on two underlying technologies, right? They're either built on Spark, or they are built on a data warehouse, right? Then they ship the data to the clients using a JDBC protocol, essentially, right? The challenges of this architecture is that, for instance, Spark has a really like a long cold start. Like if you want to start up a Spark application, it takes a couple of seconds to get up to do anything useful, to even like start retrieving the data. And that has an impact on the user experience, right? So one of the things we see oftentimes when we work with data scientists using Hopsworks and using feature stores is that what they want is they want to be able to have the same, let's say, laptop experience that they would have if they were to train on CSV file, right? Obviously, if you are a large enterprise, or if you're, if you care about data governance and you have working with sensitive data, you can't just have a bunch of CSV file flying around on the laptops of people, because that's a recipe for disaster. So you want to adopt a centralized architecture, but at the same time, you don't want to take away the flexibility in the user experience that people are used to, right? So that's what we actually try to address in the summer with Hopsworks 3.3, which essentially allow replacing the Spark query engine with a combination of DuckDB and out-of-flight, right? The basic idea here is DuckDB has really good performance, especially for point-in-time correct joins. That's a typical work use case that you see when you're dealing with feature data. And out-of-flight is a protocol to be able to ship data between client and server in a way so that you don't have to, you don't have to do a bunch of deserialization. You don't have to go from columnar format, which is the typical way the data is stored in a feature store, to row format, which is the JDBC, to back into a columnar format, which is a data frame in Pandas, right? So with out-of-flight, you can do end-to-end without deserialization, so on, right? So that's something that, as Jim was mentioning earlier, we have benchmarked. We have worked with KTH and Karolinska Institute to look at typical use cases. As I said, typical use case would be sending data to a Pandas application for training your model. So we have done actually two main experiments. One is, as I said, this one, which is basically sending data itself using DuckDB and out-of-flight, for Hopsworks, and use other technologies for the other vendors. You can see that like performance are extremely well compared to tools out there. Similar thing, oftentimes you don't want to just get a pandas data frame. Oftentimes you want to, get a materialized version of the trained data set. Maybe you're doing parameter tuning. You want to have a fixed target that you're training on. So in this case, you can potentially say Hopsworks offers the API and the old tools as well, to be able to say, okay, collect all these features in a CSV file or a TF records file. And we benchmark it as well. Again, for Hopsworks using the combination of DuckDB and Autoflight. And you can see that, again, the performance are significantly higher, both because of this implementation of point-in-time join DuckDB, but also because of the Autoflight protocol. So yeah, finally, we're looking at the inference pipeline. So the last part of the MLOps lifecycle. So basically, the inference pipeline is responsible for outputting predictions. Whether you are predicting on a single vector or you are predicting on like a 500 vector input, or a million rows or something, doesn't matter. One of the benefits of the FTI pipeline, and you can really see it here in the inference pipeline part, is the unified architecture between batch and train, right? So the feature pipelines and the training pipelines don't really need to know whether or not you're going to be doing real-time inference, or you're going to be doing batch inference, right? So the inference pipeline takes care of that complexity. All the complexity for that is included and limited to the inference pipeline itself. The inference pipeline does essentially two things, right? So and this is really important in terms of real-time use cases. The inference pipeline is responsible for retrieving data from the feature store. In Hopsworks, if you are retrieving a small set of data because you are doing real-time inference, we go to the online feature store. If you are retrieving data for like in large batches, we go to the offline part. And the other aspect it does, the inference pipeline is responsible for, is actually doing on-demand transformations. Right, so there is a class of use cases. I would argue the majority of the use cases for which some of the features data is not going to be, you're not going to be able to pre-compute it, right? It's going to come in using the request data from the request data. What we do in Hopsworks is we actually do that we use something called like pandas UDFs, right? Pandas UDFs are really powerful because you can run them on top of a pandas series. And so you can get, if you are in inference pipeline, you are in a pure Python environment. You can basically just retrieve the compute the features on top of the pandas series. But you can actually apply them if you're doing, for instance, large feature engineering, or you're backfilling a large amount of data. You can take the same feature. You can take the same feature functions as pandas UDF and give them to Spark. Spark is optimized for that. It's going to push them down to the executors. And it's going to use Arrow to communicate between the executor and the pandas UDF and make it extremely fast and extremely performant. Again, the feature pipeline, the inference pipeline, again, it combines the data coming from the feature store, combines the data from the request data and the on-demand transformations, and provides it to the model for making predictions, right? And Hopsworks as a platform provides the API to combine these two and to retrieve the data and so on, and all the metadata about which features are needed, from where they are needed, whether they need to be computed on demand or it can be retrieved immediately. It's all managed by Hopsworks, and it's all part of the Hopsworks metadata layer. And ultimately, you can make predictions. We've done a bunch of benchmarks as well for the real-time aspect as well. We'll be looking at retrieving data from the feature store. We've done it for two. Well, we've done it for more than two. You can actually look at the feature store doc/benchmarks URL that you have here. I'm going to show you like two examples, one for batch size 1 and the other one for batch size 500. 500 being a good number. That's usually a use case where you're doing, for instance, recommendation systems. That's, you have a large pool of candidates to be able to rank. You want to rank to be able to, recommend to the user. And the larger the candidate pool, then potentially you're gonna get better results in terms of more diversity of candidates to give back to the users. You can see the difference between a couple of different vendors out here, Hopsworks and a couple of different vendors. And again, you can find the code of the benchmarks to be able, if you want to reproduce them. If you want to add your own system, you can find the code in the URL itself. And yeah, and some of the other benchmarks that we have done. If you go back and we take a step back and look at the full pictures of what are the the benefits of this new architecture, this new FTI pattern, and we compare it against the data challenges that we had at the beginning. The first one being variety of data sources. The feature pipeline is the one responsible for dealing with all these data sources, all the complexity of changing or dealing with different data is all combined and constrained into the feature pipelines. In Hopsworks, the feature pipeline can be expressed with any framework, and so we're going to solve also the second challenge, which is basically say, okay, I have a bunch of different pipelines running, a bunch of different frameworks. Hopsworks can take care of all of them. Again, we provide an open API to be able to actually write to the feature store and later on retrieve features. The other challenge is the disconnection between experimentation and training and production. The new setup, the new pipelines actually allow you to register features for experimentation, and whether or not you're going to train a model, whether or not you're productionizing the model, it's the same pattern, it's the same API. It's one tool to kind of go through all the steps. This is one pattern for all of them, and it's also one pattern for doing both batch and real time. As I said earlier, the only really component that needs to be aware of whether or not it's retrieving features for a real-time request and for which he has a bunch of SLAs against, or as more like relaxed SLAs because it's a batch job running every night, for instance. It's actually only the inference pipeline, right? Training pipeline and feature pipelines are not going to be responsible for that, and they not need to be aware about the implication of where when the data is going to be needed. Now, if you want to try out this pipeline, if you want to try it out, these patterns, we actually have as Hopsworks available a serverless platform, right? It's a free sandbox that you can register. We launched it over a year ago, and we have reached over 3,500 users right now on the platform. The platform is the same as if you were an Hopsworks customer and deploy it in your own VPC on the cloud or on-prem. The same APIs, the same user experience, as the same components for feature store, so feature management, but also model registry and model service. So you can also go and serve your models directly into Hopsworks. As I said, the same user experience, same API that you will use if you were a Hopsworks customer, enterprise customer. You don't have any infrastructure to manage, so everything is managed by us. It's free, and you can just register, and there is no time limit. We built a community around it. If you go on the serverlessml.org website, you can find a bunch of different examples that you can take inspiration from. All of them follow this FTI pattern, and so you can get a feeling of what the API, what this pattern looks like in practice. And we also have two amazing integrators, Paul and Pao. They've been building a lot of tutorials and a lot of the examples for the community, and they're really active in the community and on Hopsworks. Now, the serverless platform is great, but it's not meant for enterprises. It's meant for as a sandbox for you to build your examples, or to build your own side project and so on. We don't provide any strict SLA. It's a shared infrastructure for everybody, and you have limited quotas. That we also, one of the things we actually get once we launch is we got a bunch of people asking for, okay, can I get more quotas? Can I actually deploy my own enterprise applications on top of Hopsworks, right? So that's why today I'm super excited to announce that we are actually releasing the same user experience of serverless as Hopsworks SaaS. So it's the same user experience that you find today in serverless, but targeting enterprises with both enterprise SLAs and managed platform as a fully managed platform. It has the same set of functionalities, both feature store, model registry, and model serving. It's currently being used by a couple of different small set of users, but you can register and you can join the waiting list right now by scanning the QR code. And we open up a bunch of different slots every couple of weeks. And so we're going to reach out to you once new slot becomes available. You get a bunch of quotas in terms of both online, offline, and number of models you can actually serve with, again, enterprise SLAs and support from the Hopsworks team. One of the things that really excited that we worked on really hard throughout the summer, we actually made Hopsworks available across multiple regions. This was one of the requirements that we worked with a Fortune 500 company, and this is targeting Fortune 500 companies essentially, right? So if you are, for instance, on-prem or also on the cloud, and you want to be able to, be available if one of your region goes down, now you can deploy Hopsworks so that the data and metadata gets replicated between different regions, so that if your region goes down, you can still be able to serve your applications and serve your business processes through from essentially the other region. We have, again, this is mostly to help Fortune 500 companies. As I said, we built it with a Fortune 500 company. We're going to run webinars. We're going to run a bunch of different events, going in details about these capabilities and what it means and how to deploy and so on. So you can, feel free to join us. We have a bunch of different events coming up. We're going to talk about it. We're going to be in several US cities over the course of the next couple of weeks. You can find all the events in this QR code. And that's everything for me. I don't know if there are any questions. I think I don't have too much time, but yeah, let's see if we can take them.
Thanks, Fabio. Very exciting, very interesting, and great to see the feature store platforms being pushed forward with features like multi-region, high availability, and serverless.